Next topic is another interesting topic, caching. So here we are going to talk about why caching. It's obvious, for higher performance. And we'll talk about the HTTP caching. HTTP protocol supports caching capabilities, and we are going to see how we can take advantage of those HTTP level caching. And we are going to see how cache can be revalidated. It's called the conditional get. Okay, so we're going to actually see how that can be done. We are going to also see concurrency check. It's called the conditional put. Yeah, this is almost like optimistic locking feature for RESTful application. So let's talk about each of this in a bit more detail. Why caching? Of course, faster response for the client, and it will save network bandwidth because client does not have to talk to server. It will just receive from the browser cache, or it might actually get the data from proxy cache, and it will reduce the server workload because server does not have to deal with request handling. Now let's talk about the types of caches. There are two major types of cache. One is browser cache, or sometimes it's called client cache, because in RESTful application we are not really talking about the browser, we are talking about a client, right? So client can maintain some cache, right? So it's called the client cache or browser cache in the case of a browser. Then we have a proxy cache or shared cache. So if you see the picture over here, we have a client cache here and here, which means the client is actually maintaining some data in his own cache. Okay. Now we have a shared cache. This shared cache is typically in a proxy server, and this proxy server will actually maintain some cache of the data to handle the request from the client. So it doesn't really have to go to the actual server that contains the data. Instead, it will handle the request itself. Okay. If you think about the CDN, the CDN, the content network, CDN, content data, CDN network. Yeah. So basically those CDN servers actually maintain bunch of data that will actually serve the client. So for example, like a Netflix might have a lot of proxy servers around the world that maintains their contents. So if someone in, let's say, Japan wants to actually access some movie, it doesn't have to go to the US servers. Instead, it will actually go to some, let's say, proxy server that might in fact have the movie as a cache in the proxy close to, geographically close to Japan. Okay, so let's move on to HTTP caching. So HTTP protocol defines a rich set of caching semantics in the form of request and response headers. Okay? So through the exchange of these request and response caching related headers, HTTP protocol give you a fine-grained control over the caching behavior of client cache as well as these proxy caches. The protocol HTTP also supports validation semantics, which is called the conditional get, to make managing caches much more efficient. What it means is that if cache is, if the cache is expired, the valid period of the cache expired, then the client might in fact send some kind of a conditional get to check whether the data has been changed or not. If it has not been changed, then there is no need to request the actual data to be sent over from the server to the client, right? So we're going to actually talk about this conditional get or validation semantics in detail later on. So HTTP supports this validation semantics. Now there are caching related headers. The first expires response header is, by the way, is introduced in HTTP 1.0 and is deprecated, but still supported by most browsers. More recommended, the response header is in through cache control. So cache control is introduced in HTTP 1.1, and that's something that that is recommended to be used. So let's see how each of these expires and cache control schemes can be taken advantage of to support caching. Expires header, as I said, is deprecated but still supported by most browsers. Okay, so expires response header tells the client that it can cache the data until specified time. So if the response contains this expires header with a particular point in time, what that means is that client can cache the response data until this specified time. Pretty straightforward concept, right? Now, how you are going to set this expires request header? It's pretty straightforward. Remember request builder class. If you remember request builder class, it does have expires method. So this expires method is used to set expires response header with the date object here. Okay, so expires method is used to set expires response header. Now, as I said, cache control response header is actually recommended scheme, and the reason is because it actually provides much more explicit control, much more fine-grained control and explicit control in terms of the where and how long the cache is supposed to be maintained. Okay, so it also actually supports cache revalidation or conditional get. That logic is actually, the conditional get scheme is introduced as part of the cache control scheme in HTTP 1.1. It basically addresses the limitations of expires header-based caching scheme introduced in 1.0. Okay, so the cache control directive. So let me actually show you the actual response from the server. So the server, when it sends back the response, it could actually set this cache control response header. So, and with the set of what is called the cache control directive, private, no store, and max age, these are all examples of cache control directive. So let's take a look at the complete list of cache control directives. First, private versus public. So it actually specifies who can cache the response. So when private is sent, what that means is that the client can cache, but proxy cache cannot. So the reason it's called the private is because it's private to that client. Proxy, if you think about it, that's actually a public proxy server, right? So anybody can actually access that proxy server, so it's not private, right? Okay, so if you set private as I have been showing you here, that means the response data should be cached only by the client, not proxy server. Okay, however, if the directive is set as a public, then both client and proxy server can cache the response. Okay, so private versus public, it specifies who can cache. Max age, in terms of seconds, it lets you specify how long the cache is going to be valid. So it specifies duration of the valid period. Okay, now you could in fact have expires header as well as max age directive. In that case, max age is the one that will be used. Okay, no cache directive specifies how to cache, indicating that the response should not be cached. Okay, so if you if you are building an application and you do not want nobody cache your response, then you can specify no cache. No store indicates the browser and proxy cache should not store the data in disk. So the proxy server and the client might in fact actually save the data that was returned, a response, into the disk, for the sake of maybe saving memory space or something like that. If you do not want that to happen, then you can set no store directive. hold a second, let me just, okay, sorry about that. No transform directive indicating the proxy caches should not transform their cached data. Some proxy server might in fact actually compress the data or something like that, and if you do not want that to happen, then you can send no transform cache control directive. The last one is must revalidate. Again, it specify how to cache. Basically, browser should always check with the server before it serves up a page, meaning response from the cache. So basically, regardless of validation period, the browser has to ask the server whether data has been changed or not. Okay. So again, you can use this must revalidate directive to make sure that the client always in fact have up-to-date data. Okay, so those are cache control directive, and again, those directives could be specified in cache control, the response header. Okay. Now, how you can set this cache control response header in JAX-RS? JAX-RS in fact supports, it provides the cache control class for constructing cache control response header with the directive you talked about. So here, let's say we have a get customer method returning response object. So here we are going to create empty cache control object here, and then we can set the max age of 500 seconds. We can set private, so it will set private the directive, and no store directive. Okay, and then you are going to call cache control method of the response builder, passing cache control object that you just created. Okay, so pretty straightforward. Okay, so let's do exercise 1. So exercise 1 is in fact playing around with the cache control. So let's see cache control application. So here, so let's run this guy. Run on server and Tomcat. Okay, so while it's starting, let's see what we can do. So here we are going to get the first customer detail information, and we're going to actually get it with the developer tool in Chrome, and we just want to observe cache control the response header, and in this case it's set with the private and no store, no transform, max age, and things like that. So if you take a look at the code, this is basically creating a cache control object with the max age, private, no store, and then we just call cache control method. Okay. Alright, so let's actually do this. Okay, so here we are going to alright, so we are going to click this guy. Alright, so we are going to see the response header. So you can see cache control is set private, no store, no transformation, and max age is 500 seconds, right? So again, if you take a look at the code here, let's see the server side code. Server response, we are talking about the particular customer. So this is the one, get customer, and we are basically for that customer we are setting the cache control. Alright, so if you want to actually set, let's actually change the value to 600, and private, set private false. Okay, no store false. So let's just change this guy and see whether they are being reflected. Okay, so let's wait until it is reloaded. Okay, so it's reloading, it's completed. Now let's try again here. Right, so let's just clear this guy up, and here. Okay, so now let's see the here, and cache control is now set with so cache control is, this is actually request header, so I'm actually looking for cache control in the response header. So no transformation, max age 600. So that's basically what we said, right? And no store is no store. What was the no store? No transformation. Okay, so let's actually see if you take a look at the, let's actually see the cache control class, shift F2, and what other method we can actually use. So basically we have set no store boolean, set no cache, set no transformation, set private, set proxy validate, revalidate, set max age, and things like that. Okay, so that is how it works. Modify get order method of orders cross server application to set the cache control response header, and verify it using Chrome browser's developer tool, or modify the client application to display the response headers. Okay, so I'm going to give you guys 10 minutes to try exercise 1.3 and for your own exercise 1.3.